Right, good morning. So let's talk about the topic of permittivity. Okay, so you see this topic as part of the electrostatics. So permittivity, is associated with generally associated with insulators. Okay, and when you do Coulomb's law, the force of attraction or the repulsion between the two charges is expressed as you know the product of the two charges and the square of the distance between them. And additionally, it depends on the permittivity of the medium between the two charges. I'm just highlighting this. So this is the permittivity of vacuum, and this represents vacuum, permittivity. But and we have two charges which are Q1 and Q2, which are separated by vacuum. Now, if you introduce a dielectric, which is an insulator, other than vacuum, for example, you introduce some dielectric, okay, between these two, and the medium changes to some vacuum. This could be mica, for example, right? The new force of attraction or repulsion will become 1 4 pi epsilon medium multiplied by Q1 Q2 upon R square. Okay, and epsilon medium is greater than epsilon naught. So this is some insulator. Okay, and this is vacuum. Okay. As you can see, the mica, for example, the permittivity is much greater than that of vacuum. So the force, which is the electrostatic force between the two charges, goes down because of introduction of an insulator. Okay, so insulators have this property of permittivity, and the presence of an insulator between the two charges weakens the electrostatic force between them. And if you associate this with the real world and you have a jar in which you place some water, the water will, is, and you shift, what you do practically is put some salt in water. For example, I represent salt with some color, and this is the salt, which is your table salt, which you insert, right? As soon as the salt enters the water, now water's permittivity, epsilon, is 80 times the permittivity of vacuum. And therefore, the electrostatic force between the sodium ions and chloride ions, the force between these two reduces drastically. So, sodium ion and chloride ion, which are otherwise very tightly bound in vacuum, suddenly when they are inside water, which has very high permittivity, the force, the electrostatic force between these two ions, which is sodium and chloride, goes down drastically, and therefore it dissociates and separates out as sodium and chloride ion in water, right? So you should know this is a practical example how permittivity has the capability to influence even chemicals, and sodium gets dissociated, because of increased permittivity and reduced electrostatic force between the charges. Thank you very much.